All right, so you wanted to get a grip on Linux file permissions.
Yeah,
We're diving deep this time into how Linux handles that whole thing of keeping files and directories secure,
absolutely. It's a big deal.
especially right when you've got multiple people
Yeah.
using the same system.
A multi-user environment. You got to
Yeah.
keep things locked down.
We're going to be looking at the ins and outs of users and groups
Right.
and those essential permissions. Read, write, execute.
The Holy Trinity.
Yeah, absolutely. And, hopefully by the end of this, you're going to be able to, just glance at a directory listing and know exactly what's going on.
That's the goal, going from a jumbled mess
Yeah.
to a clear picture of who can do what.
Exactly. So no more accidental deletions.
Right.
Or security breaches
Yep.
because someone left a file wide open.
Precisely. And our sources really hammer that home. The security implications are huge.
Yeah, I mean it's kind of the foundation of the whole multi-user security model in Linux.
So without it, you're just asking for trouble.
All right, so let's start with the basics, right?
Okay.
We've got users,
Right.
and we've got groups.
The building blocks.
Now there's this one special user, the root user,
Yeah, the all-powerful admin.
Exactly, the one with the keys to the kingdom.
Right. They can do anything, go anywhere.
And then of course you've got your regular users, like us.
The mortals.
Yeah, we have limited privileges.
Right. Just enough to do our jobs, hopefully.
Now to keep things organized, users are often put into these groups.
Makes sense.
Think about it, your finance team,
Right.
your engineering team.
Your developers?
Instead of setting permissions for each individual user.
Which would be a nightmare.
Right, a complete nightmare.
You just set it for the group.
Exactly, and then anyone in that group inherits those permissions.
Yeah, it streamlines the whole process.
So efficient.
Imagine a company with hundreds of employees trying to manage that individually. Chaos.
Chaos, utter chaos. Now let's break down the actual actions users can take, right?
Okay.
We've got the famous trio: read, write, execute.
The essentials.
So read, obviously, that's looking at the contents of a file.
Peeking inside.
It means you can make changes.
Modify, edit, delete.
Exactly. And execute means you can run it.
Like a program or script.
Right. So when you create a file, you're usually the owner, right?
Yeah, the proud parent.
And it usually belongs to your primary group.
Like by default, yeah.
But what if you need to give someone else control, full control?
Ah, delegation of power.
Exactly. That's where the chown command comes in.
Right, so chown changes ownership.
Right. So if I wanted to give you ownership of a file called Bob's file in the temp directory,
Okay.
I would type kali chown Bob temp Bob's file.
Makes sense.
And boom, it's yours. You're the owner.
I'm in charge now.
Exactly. And for groups, it's the chhgr command.
Right, so chhgr changes the group owner.
Right. So kali chhgrp security new IDs.
Giving the security group ownership of a file.
Exactly. Maybe it's some sensitive log file or something.
Right, or a new intrusion detection system maybe.
Right. So you can see how this is already getting
Yeah, pretty powerful stuff.
really important, right, in terms of controlling who has access to what.
Absolutely, and thinking about it from a hacker's perspective, this is crucial too.
Oh, yeah. If they can manipulate these permissions,
They can gain access to sensitive data.
I can potentially take control of the system.
Right, so understanding this is key for both defense and offense.
Okay, so how do we actually see these permissions?
Right. How do we know who can do what with a given file?
So the command we use is lslo.
The long listing.
Yeah, gives you all the juicy details.
Right, a lot more info than just a plain else.
Now, the output might look a little intimidating at first,
It's a bit cryptic.
but once you break it down...
It's actually pretty straightforward.
Okay, so each line represents a file or directory.
Right, and the very first character tells you if it's a file or a directory.
A dash means it's a file.
Right, and a dia means directory.
Then comes this, string of letters.
That's the permission string.
It's always 10 characters long.
The first character is that file type indicator, dash or D.
Right. And then you have 3 sets of RX.
Or dashes if a permission is missing.
The first set is for the owner,
Right, the second set is for the group.
and the last set is for everyone else.
The world.
So, for example, let's say we look at a file
Correct.
called hashcat.hcstat in the averse-share hashcat directory, and it shows this permission string.
Okay, what does it say?
It says rww-rr.
Okay, so let's decode that.
Okay, so we see a dash at the beginning, so we know it's a file.
Like this.
Then RW,
So the owner can read and write.
but not execute it.
Right. No AX step.
Then for the group and everyone else, it's R.
So they can only read it.
Exactly. They can't modify it or run it.
So it's like a read-only document.
Exactly. And, you can get this kind of information for every single file and directory on your system.
It's all laid out there for you.
Yeah, it's really powerful.
Definitely a good habit to check permissions regularly, especially on sensitive files.
Absolutely. So now that we can see the permissions...
How do we change them?
Good question. The command for that is chmod.
Powerful command.
It is, but it's also, you got to be careful with it.
Right. Only the root user or the owner can change permissions.
Exactly. So there are two main ways to use chmod.
Okay, what are they?
The first is numerical, and the second is symbolic.
Two different approaches.
Yeah, so let's start with numerical.
Okay.
It's a little bit, it can be a little confusing at first.
I can see that.
But it's actually quite logical once you get the hang of it.
Okay, let's break it down.
Okay, so think of each permission, read, write, execute, as having a point value.
Okay, like a game.
Kinda, yeah.
All right, I'm listening.
So read is 4 points.
Got it.
Write is 2 points.
Okay.
And execute is 1 point.
So 4, 2, 1, read, write, execute.
Exactly. So to set the permissions for owner, group, and others, you just add up the points for each.
Okay, I see where this is going.
So for example, if you want the owner to have read and write permissions,
Yeah.
that would be 4 plus 2, which is 6.
Right, 6 for read and write.
Exactly. And then let's say you want the group to also have read and write.
Another 6.
Yep. And then maybe others should only have read access.
So that's just 4.
So you would use chmod, followed by those 3 digits, 664.
Okay, so it would be chmod 664.
And then the file name.
Right, so like Kali chmod 664 hashcat.husat.
Exactly. And that would give the owner and the group read and write permissions.
And everyone else just read permission.
Precisely. It's like a little code.
Yeah. Once you understand the numbers, it's very efficient.
Okay, so now let's talk about the symbolic method.
All right, the other option.
It uses letters instead of numbers.
So maybe a bit more intuitive for some people?
Yeah, maybe. So you use U for the user,
Okay, U for user,
G for group,
G for group,
and O for others.
O for others. Easy to remember.
Then you use a plus sign to add a permission, a minus sign to remove a permission,
Yeah.
and an equal sign to set the permissions. Absolutely.
So we're adding, removing, or setting.
Right, and then you just specify the permission you want to change, R, W, or X.
So like U plus X would give the user execute permission.
Exactly. Or GW would take away write permission from the group.
Makes sense.
So let's say you download a script from the internet and you want to be able to run it.
Okay, so you need execute permission
You could use chmod U plus X script name.
to give yourself permission to execute it.
And if you wanted to let everyone execute it,
Then chmod U plus X, O plus X script name.
right, adding execute permission for both you and others.
That's handy, yeah.
So the symbolic method can be a little easier to read.
Yeah, it's more human readable.
But honestly, I think it's good to be comfortable with both methods.
Yeah, they both have their uses.
Now, here's a little wrinkle.
Okay.
When you create a new file or directory, Linux actually assigns default permissions.
So even before you set anything manually.
Right, so for files, the default is usually 666.
Okay, which means everyone can read and write.
That seems a bit open.
Yeah, it's not very secure, right?
Definitely not.
And for directories, it's 777.
So everyone has full access.
Yeah, so obviously we need a way to like rein that in a bit.
Tighten things up.
And that's where the mask comes in.
The on-mask, what's that?
It's like, think of it like a stencil
Okay.
that removes permissions from the default.
So it makes things more secure by default?
Exactly. So a common mask is 022.
Okay. 022.
And if you subtract that from the default 666 for a file,
You get 644.
right, which means the owner can read and write
And the group and others can only read.
much better.
Yeah. Much more sensible.
And Kali Linux, by default, uses a mask of 022.
So things are pretty locked down out of the box.
Yeah, you can check your own mask by just typing a mask at the command line.
Handy to know.
And you can change it too, if you need to.
How do you do that?
You can edit your .profile file, which is like a setup file for your user account.
Okay, so it's a customization thing. Exactly. Now we need to talk about some special permissions.
Special permissions, it sounds intriguing.
These are, they're a bit more advanced.
So important, I bet.
They are. They can be really powerful, and they can also be like a security risk if they're not used properly.
Okay, I'm all ears.
So the first one is SUID,
SUID.
which stands for Set User ID.
Okay. Set user ID.
And what it does is it lets a file be executed with the owner's permissions.
Even if you're not the owner.
Exactly. So, like, think about the password command.
Okay, the command to change your password.
Right. You need root access to actually modify the password file.
Right, because it's a sensitive system file.
But you don't run password as root, do you?
No, you just run it as yourself.
Right, and that's because password has the SUID bit set.
So it runs with root's permissions temporarily.
Exactly, so you can change your password even though you're not root.
That makes sense, but it sounds a bit risky.
It can be, yeah, if there's a vulnerability in a program that has the SUID bit set.
An attacker could potentially exploit it.
Yeah, they could potentially gain root access.
So it's like a backdoor if it's not handled carefully.
Right, so you can actually search for files with the SUID bit set.
How do you do that?
You can use the find command, like kali find deuce user root dsperm dece 4000.
What does that do?
It searches the entire file system for files owned by root,
Okay.
and that have the SUID bit set, which is represented by the number 4000.
And what would you see in the output?
You might see things like a Serbin password,
Right, we talked about that,
or a Serbin sudo.
which lets you run commands as another user.
Exactly, and if you look at those files with ls dsl,
Okay.
you'll see an S where the X for execute permission would normally be for the owner.
So instead of SSRSRX, it might be SUID bit is set.
So that's the telltale sign.
Now, the other special permission is SGI.
SGID, set group ID.
You got it. It's similar to SUID.
But instead of using the owner's permissions...
It uses the group's permissions.
Okay, I see.
So if a file has the SGID bit set, anyone who executes it will run it with the permissions of the group that owns the file.
Exactly. Now, SGID works a little differently on directories.
Okay, so.
When SGID is set on a directory, any new files created inside that directory will inherit the group ownership of the directory.
So it's about controlling group ownership.
Right, and it's represented by a 2 numerically instead of a 4.
Okay, so SUID is 4, SGID is 2.
Exactly, and just like SUID, SGID can be a security risk if it's not used carefully.
Right, because it can also be exploited for privilege escalation.
So you really have to think about the permissions you're setting and who needs access to what.
It's all about balance, isn't it?
Yeah, between functionality and security.
You want things to work smoothly, but you don't want to leave the door wide open for attackers.
There's also this thing called the sticky bit.
Sticky bit?
Yeah, it's another special permission.
What does it do?
It's kind of a legacy thing.
Legacy?
Yeah, it used to be more important.
How so?
It used to prevent users from deleting or renaming files in a directory.
Unless they owned the file or the directory.
Right, it was used in, like, shared directories.
To keep things organized.
Yeah, but these days, most modern Linux systems just ignore the sticky bit.
So it's not really relevant anymore.
Not really, but it's still good to know about it, just in case you ever come across it.
Okay, so to recap, we've covered users, groups, the 3 basic permissions.
How to change those permissions with chown, cheach, grp, and chmod.
Both numerically and symbolically.
The role of the mask in setting default permissions.
And those special permissions, SUID and SGRT.
And why they're so important from a security perspective.
Absolutely. It's been a great overview. I think people now have a much better grasp of how Linux handles file permissions.
Yeah, what once looked like gibberish should now make a lot more sense.
It's like learning a new language.
And once you know that language,
you can start to see the potential vulnerabilities.
And you can also start to see how to really lock down your system.
Exactly. Knowledge is power.
So here's something to think about. We've seen how these seemingly small settings,
like file permissions,
can have a huge impact on security.
It's all interconnected.
What other hidden mechanisms might be out there?
Lurking beneath the surface.
Governing access and control in our digital world.
That's the question.
And that's your deep dive for today.
Food for thought.
Until next time.